Hi everybody, this video is going to be over the sum and difference identities day 2. So in this one, we're going to focus on dealing with radians. When you have radians, you have two different options. Option number 1, you deal with the radians, so you get common denominators. Option number 2, you switch the degree, you switch 2 degrees by multiplying by 180 over pi. In the focus of this video, I'm going to focus on number 1, but I will show you what number 2 looks like as well in one of the examples. So again, we have our sum and our difference identities. So let's look at example number 1. Example number 1, we want to find the exact value of cosine of 5 pi over 4 minus pi over 6. So we see that these two are being subtracted, therefore we're using the difference formula, and we see that the trig function is cosine, so we use the difference formula for cosine. We get cosine of A minus B is equal to cosine of A times cosine of B minus, or plus, I'm sorry, sine of A times sine of B. So what we do here is we're going to plug in 5 pi over 4 for A and pi over 6 for B. So what that gives us is cosine of 5 pi over 4 times cosine of pi over 6 plus sine of 5 pi over 4 times sine of pi over 6. So what we do here is we start evaluating. What I need you to know is that 5 pi over 4 is in the third quadrant. It is in the third quadrant, and in the third quadrant, sine and cosine are both negative, so make sure we keep that in mind. For cosine of 5 pi over 4, we put down the middle finger because the denominator is 4. Cosine is on top. You should have 2 fingers on top, which gives us rad 2 over 2. And because it's in the third quadrant, it becomes a negative rad 2 over 2. For cosine of pi over 6, you put down your ring finger. Cosine's on top. You have 3 fingers. And that gives us rad 3 over 2. Pi over 6 is in the first quadrant, so it is positive. Then we move on to sine of 5 pi over 4. So again, the middle finger goes back down. Sine is on bottom. So we get a negative rad 2 over 2. Sine of pi over 6, you put down your ring finger. You have 1 finger left on bottom, so you get 1/2. Now all we're going to do is simplify this. So I'm going to multiply a negative rad 2 times rad 3. That gives me a negative rad 6. I multiply the denominators, 2 times 2, and it gives me 4. Then I am going to multiply a negative rad 2 times 1, which gives me a negative rad 2. Then I'm going to multiply 2 times 2 and get 4. And last but not least, I'm going to write it as one big fraction all over 4. So I have a negative rad 6 minus rad 2 all over 4. And this right here is my final answer. So to check our answers, we can use the calculator. So if I switch over to the calculator, I'm going to go to a new calculator document. And what we need to do now is we need to switch to radians because that's what we were given. So I'm going to switch to radians, and I'm going to type in cosine of 5 pi over 4 minus pi over 6, and I'm going to get a decimal. Then I'm going to type in the answer that I got, which is negative rad 6 minus rad 2 all over 4. So I'm going to put 4 in the denominator, And it shows me that I get the same exact answer for both of them. So that is how you can check your work. Now, we're going to go back and we're going to go to the next one. So example number 2, it says find the exact value of sine of pi over 12 plus 7 pi over 12. Well, if we think about it, our hand trick only covers denominators that have 6, 4, 3, and 2, and 12 is not one of those. So we actually don't know this value. So what we're going to do instead is we're actually going to add these two fractions together to see if it's something we know. So this is a 1 pi over 12, and I'm going to add 7 pi over 12. When I add fractions, I add the numerators, and I get 8 pi. The denominator stays the same. Now, I still don't know what that is, but I do realize that 8 and 12 can be simplified. Both of those numbers are divisible by 4, so I'm going to divide both of them by 4. So I get sine 8 divided by 4 is 2 pi, and 12 divided by 4 is 3. 2 pi over 3 is an angle we should know. So to find sine, we're going to put down the index finger, and we see that we have 3 fingers left in the denominator. So I get rad 3 over 2. Now you have to determine what quadrant this is in to determine if it should be positive or negative. So if you notice, 2/3 is really close to being 3/3, but it's less than 3/3, which means it is in the second quadrant. And in the second quadrant, sine is positive, so our answer is just rad 3 over 2. Looking at our next one, we want to calculate the exact value of cosine of pi over 12 by using the difference identities. It tells us that we are using the difference identities and we are using cosine. So the cosine difference identity, we use this in example 1, is a minus b equals cosine of a times cosine of b plus sine of a times sine of b. What we need to do is we need to identify 2 angles that can be subtracted to give us pi over 12. Remember, when it's the difference, A does need to be the bigger angle. So off to the side, this is where we do our math. So pi over 12 is an angle that I don't know. I need to figure out angles that I can subtract. So I'm going to start adding angles. If I try to add pi over 12, that's not going to do me any good because I don't know this angle. That's the whole reason we're doing this. So pi over 12 is not going to be helpful to use. So instead, if I go to 2 pi over 12, we're going to see if maybe we know this. Well, 2 pi over 12 can simplify to pi over 6. I know that angle. So if I add them, I get 1 pi plus 2 pi. That gives me 3 pi. And my denominator stays the same. And then I check to see if I can reduce that fraction. This fraction reduces the top and the bottom by 3, which gives me pi over 4. I know that angle. So since I know both of those angles, I can use them for my difference formula. Now again, the bigger angle needs to be A, and in this case, pi over 4 is the bigger angle, and pi over 6 is the smaller angle. So what I'm going to do is I'm going to plug in those values for A and for B. So I have cosine of pi over 4 minus pi over 6 equals cosine of pi over 4 times cosine of pi over 6 plus sine of pi over 4 times sine of pi over 6. So now I start evaluating. All of my angles are in the first quadrant. So here we go. Cosine of pi over 4 should be rad 2 over 2. If you want to pause the video to try to answer them, to check your understanding of the unit circle, that would be a great idea. Cosine of pi over 6 is rad 3 over 2. Plus sine of pi over 4, that is rad 2 over 2. Times sine of pi over 6, that is 1/2. When I multiply these together, I get the square root of 6 over 4 plus the square root of 2 over 4, which allows me to write it as one big fraction, the square root of 6 plus the square root of 2, all over 4. If you notice here, my answers when we are using the sum and difference identities are usually pretty similar in the aspect of it has a rad 6, it has a rad 2, and the denominator is 4. Typically for sine and cosine, that's what we will get if we are using a sum and difference identity. Be careful because example 2 did not require that identity, so when it doesn't require it, we don't do it, because it would simplify and it's an angle we already know. We only use the identities when we don't know how to identify the angle. Okay? Now, in example 3, I am going to show you the other method that we can do, which is switching to degrees by multiplying by 180 over pi. So what we're going to do here is we are going to calculate the exact value of sine of 5 pi over 12 by using the sum identities. So what I'm going to start by doing is I'm actually going to, first I'm going to solve it using radians, then I will solve it using degrees. Okay, so first thing we're going to do is we want to use the sum identity for sine, so I'm going to write that out. So the sum identity for sine is sine of a plus b equals sine of a times cosine of b plus cosine of a times sine of b. So we're going to find two angles that can add to give me 5 pi over 12. Same concept as we did before. So I have 5 pi over 12. I don't know that angle. I'm going to subtract angles from it. Again, I'm not going to use 1 pi over 12 because I do not know 1 pi over 12. So I'm going to jump to 2 pi over 12. And earlier we talked about 2 pi over 12 being pi over 6. So when I subtract, 5 pi minus 2 pi is 3 pi over 12. So that was pi over 4. Those are the two angles that I'm going to use to add to get me 5 pi over 12. So for this one, it does not matter which one is A, which one is B, because it is the sum identity. So I'm going to let pi over 6 be A and pi over 4 be B. I'm going to plug them into the formula. So we have sine of pi over 6 plus pi over 4 equal to sine of pi over 6 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. I'm going to evaluate these angles. So sine of pi over 6 is 1/2. Cosine of pi over 4 is rad 2 over 2. Plus cosine of pi over 6 is rad 3 over 2. And sine of pi over 4, I did not need to write sine, is rad 2 over 2. So when I multiply these together, I get rad 2 over 4 plus rad 6 over 4, which leaves me with rad 2 plus rad 6 all over 4. So this is showing you using radians. Now I'm going to rework this problem and show you that you can get the exact same answer if you switched it to degrees. So if you're not one that is comfortable with radians, what we're going to do is we're going to take our angle 5 pi over 12 and we're going to multiply it by 180 over pi. You can do this directly into your calculator. Okay, so if I switch over to my calculator, if I do 5 pi over 12, and pi is next to the keyboard, it's one of the first buttons, I think on the third row, the first button. Then I'm going to multiply by 180 over, oops, that's not what I wanted. So let me do the fraction first, then 180 over pi. I multiply them together and I get 75 degrees. So what we can find, or what we can do now, is we can break down sine of 75 degrees. Okay, so if I think about two numbers that can add to get me 75 degrees that I know, I would use 45 degrees plus 30 degrees. That would give me 75 degrees. So now we're going to plug them into the formula. Let's see if I have enough space here. I have sine of 45 times cosine of 30 plus cosine of 45 times sine of 30. What we're going to do is evaluate. So sine of 45 degrees is rad 2 over 2. Cosine of 30 degrees is rad 3 over 2. Plus cosine of 45, that is rad 2 over 2. And sine of 30 is 1/2. I multiply together, I get rad 6 over 4 plus rad 2 over 4. And so that gives me rad 6 plus rad 2 all over 4 as my answer. And if I double check to make sure, I got the exact same thing in the other one. It's just my top was written in the opposite order, but since it's addition, it's all good. So I showed you how to solve using radians. I showed you one way with degrees. So if you wanted to switch all the angles in examples 1, 2, and 3 into degrees, you could do the same thing. If you have any questions, please write them down and make sure you ask in class.